Good morning, good noon, and good night. Welcome to Learning Cafe, where we make learning while having fun manageable. Once again, I am Lian, yeah. And this is a supplemental video related to managing data. Here we will solve two real applications that uses the concepts that we have discussed previously. Let's take a look at the examples that I have taken from BC Campus Open Publishing. Okay. One, the bar graph indicates the average meeting time for Canadians 2016. Here are the 7 questions. According to the graph, what was the average meeting time for all Canadians? 26.2, as you can see in the graph. Next, which province had the highest meeting time and estimated time? So you can see here, Ontario has the highest meeting time with an average of 28 to 29 minutes because it's not yet hitting in the 30-minute mark. Next, which province had the lowest commuting time? As you can see, it is Nunavut with an estimation of 10 minutes because it hits exactly the 10-minute mark of the graph. Next, which province or territory's commuting time was also the average? As you can see, we'll have to look at the Canadian average and then look at the different bars on the graph. As you can see, BC has the closest, but it is the one nearest to the average. Next, name all provinces or territories with a commuting time greater than the Canadian average. Now, all you have to do is look at the Canadian averages again and look at the bar that exceeds the line here, which is Ontario. Next, name all provinces or territories with the commuting time less than 20 minutes. All you have to do is look at this, the 20-minute mark, and just list all the provinces or territories that are below this line. Next, last, which province or territory best represents the median commuting time? As you can see, all I have to do is add all the values or estimations of each of the time, and let's say divide it into how many provinces or territories there is in the graph. After doing that, we can see that NL has the, let's say, best representation of the median waiting time because it is the one that is, let's say, closest to average. Next sample problem. A recreational basketball league gathered information on its players. Tally for the players' heights in feet and inches is provided below. So you can see, this is the data we will use. Number 1, create a frequency distribution table that shows both the absolute and the relative frequencies. Next, determine the mode and the median. Create a bar graph to illustrate this data, and are there any outliers, and why does the bar graph not depict this? Okay, this is the frequency distribution table. This is the absolute. This is the relative frequency. Absolute is basically what is the total times that these values have been repeated in the tally. Next, for relative frequency, all we're going to do is we're going to add all the times that each value has been added in the tally, which totals to 72. And all you're going to do is you're going to divide the values by 72 to get the percentage in the relative frequency. For example, 2 over 72 is equals to 0.27, I think. Somewhere close to that. Add up, it becomes 3%. Next, for the next mode is in median. Mode is basically the value that appears the most in the data set, which is, as you can see from its absolute frequency, you can see that 6.2 appears the most with 12 times, and pretty much that is the mode. For the median, once again, we're going to add all the values and average them. Add them all, average them according to how many they are, and after doing that, the result will be 6 feet and 4 inches. Next, as you can see, question number C just asks us to create the bar graph. Okay, this is illustration or the bar graph. Next. Now, finally, are there any outliers? Okay, as you can see, 5 5 is an outlier. This not obvious for the bar from the bar graph since the measures from 5 5 to 6 1 have been omitted from the graph, so the gap between 5 5 and 6 1 is not apparent. Basically, yeah, we can say that 5 5 is an outlier, but we can't actually prove it using the bar graph alone. You have to compute it. But after computing that, we can see that 5 5 is an outlier. That ends it for our discussion. And yeah, thank you for listening and hope to see you soon.